Okay, so if you are trying to decide where to build in the generative AI landscape, or you just want to figure out, you spec have a better understanding of the landscape, Madrona Ventures came out with a recent blog post basically breaking down, creating a framework for the 5 parts of the Gen AI landscape. So on the top of the framework is the application layer. That's where you see content generation, some of the consumer use cases. And then below that, you have application frameworks, models, data loaders, um, and then also the evaluation platform, and then something to manage your code in deployment. So let's dive into those 5 parts. So in particular, let's focus on the infrastructure layer. One is how to manage your application frameworks. So application frameworks would be something like LangChain. Um, LangChain is the most popular, and what these really do is they simplify your development process. They help you iterate quickly. They shorten your development times. And the basic idea is you don't need to have the domain expertise in AI or deep learning. You can just bring your domain expertise and your understanding of your customers. You don't need to, for example, train your or build pipelines for your LLMs and your data loaders. So some examples that you can use this for is you generating content, creating semantic search, autonomous agents, and then you have the model layer. So this is models differ based off of the output quality, the model size, the cost, the latency. So for example, if you go with a larger model, you might be able to get higher accuracy, but at a higher latency as well. And so some of the platforms in this space are, you have the foundational models, right? Those are developed by Cohere, Anthropic, OpenAI. You also have hosting options, so you can deploy models not just to a GPU cluster, but also into a browser. And then if you want to train your own models, for example, for fine tuning, you have companies like Cerberus, Mosaic ML, that you can pay to use their platform to manage your training. Another component, so we've talked about the models, there's also the data layer. So this is where a lot of the traditional software players are in. So you have, what are the different types of data? You have structured and unstructured. So structured would be from a database, whether that's a SQL or non-SQL a NoSQL data. And then you also have unstructured data, which would be what most companies are sitting on: PowerPoint slides, PDFs, HR, recruiting documents. And so examples of companies that help you retrieve that data are Databricks, Airbyte. Um, and so those are some of the traditional players, but there's also newer players on the scene, or at least new applications that have emerged. Those examples of that would be the vector database. So the key problem you're trying to solve there is you're trying to do semantic search or conversational interface, and you want to make sure you're answering questions in a meaningful way, as opposed to maybe matching your information or finding information based off just the pure text. You want to look for meaning. And companies that help here are companies like Pinecone and Redis. So Redis, right, was really popular for their caching technology, and they've recently moved into vector databases as well. But what has really come off has really kind of scaled quickly and rapidly in the open source community is Pinecone. So that's one particular technology, the vector database that you can be using. Um, Now, in terms of, okay, so you have your data, you have your model picked out. How do you evaluate performance? Well, in particular in generative AI, there's one, you have to think about prompt engineering. So how do you determine the best prompts? What has performed the best in different situations? Some companies in this space would be prompt layer, human loop. And then there's some traditional ML players that help you with experimentation. So how do you provide experimentation offline or online? Players here would be something like ML flow, weights and biases. Um, ML flow is really predominantly open source, and so that has gotten a lot of traction for keeping track of hyperparameters, fine tuning, and labels. And then you also think about, in traditional software, we have observability companies like Datadog, Dynatrace. That has also emerged in generative AI. So you have companies like Y Labs and Arise, which Arise is a little bit earlier stage, but that helps you keep track of model performance, the cost of inference, the latency of inference for your different models. And then once you've evaluated your model, you have your data, you have your model picked out. How do you then deploy that model? So traditionally what I've been using is um, uh, Amazon SageMaker, but Some new tools have emerged, such as Gradio, Fixie, Steamship, and so as you know, with this new landscape, there's going to be new tools that emerge specifically for generative AI applications. So there's a an overview of where you could be building, not just in the applications, but looking deeper into the infrastructure that's used to build generative AI applications. That's in your application frameworks. So open source tools like LangChain. There's also data loaders, model managers, evaluation platforms, and deployment platforms. Whether that's larger scale like AWS SageMakers or sort of newer on the scene like Gradio or Fixie.